continue our lesson on compounds. We've just discussed a ionic compound in terms of metal to nonmetal with an electron transfer. We're going to introduce just briefly a second category of compounds known as molecules. We are on page 7 of our note pack, just to kind of show where my note pack is. Open to page 7. Let me bring that up high. And kind of skimming down to where we finished like a review section from the previous video lesson. And I'm on chapter 6, molecular compounds. From there, we'll go back to the PowerPoint and show our definitions and examples. Turning gears, shifting gears, ionic compounds, I think salts. Ionic compounds are built of formula units. Ionic compounds, metal to nonmetal. I am now turning the page and introducing an entirely new category of compound. The second category of compound is known as a molecular compound. Page 7 of our notes. Please define with me that molecules are the smallest building block. They are electrically neutral. Just as atoms build elements, molecules are the building blocks of molecular compounds. Now, very clearly, I'm going to write a note from the last category. Ionic compounds are built of charges. Ionic compounds made from metals which are positive, hooking to nonmetals which are negative, and our goal is to have enough of each type of ion to create an electrically neutral compound. And I turn the page, introducing the second category. This is so extremely important to notice. They are electrically neutral. When molecules form, there is no such thing as charges. They form a bond in a completely different way, giving them a completely different set of properties as our salts, known as ionic compounds. Molecules are the smallest electrically neutral unit of a substance that still retains the properties of the substance. Molecular compounds are built of molecules. Ionic compounds are built of formula units. The individual repeating pattern of a crystalline array are known as formula units. Molecular compounds are built of molecules, the basic building blocks. Atoms build elements. Formula units build ionic compounds. Molecules build molecular compounds, the basic building blocks of matter. And just depending on what those building blocks are composed of is why we have a variety of different types of naming systems in the nomenclature for chemistry. When elements of non-metals come together, we create molecular compounds. Molecules are made of a metal to a non-metal. The types of elements that are chemically bonded together in a molecule are non-metals. Molecular compounds is when a non-metal combines with a non-metal, we get molecular. If we had a metal to a non-metal, we get ionic, which are built of formula units. Ionic compounds, metal to nonmetal, formula units. Molecular compounds, nonmetals plus nonmetals acting as a unit that are electrically neutral. Since we have nonmetals grouping together, forming a completely different variety of compounds known as molecules, they have completely different physical properties. Let's talk about how the bond forms. The type of bond, known as a covalent bond, talks about sharing electrons. Atoms that share electrons literally by overlapping their orbitals become a covalent bond. Perhaps the simplest, and please draw this with me, would be to represent a hydrogen molecule, H2. I might have this on a room for a slide. Let me have a little more room. I do. Here's our next slide. Let's model a little bit about covalent bonds with probably the simplest of all, showing how a hydrogen molecule bonds. Well, if I just consider hydrogen, simplest out of them all, mass number of 1, atomic number of 1, a simple model shows 1 proton and absolutely no neutrons. 1 minus 1 is 0 neutrons. And in that outermost energy level is a single electron. I'll draw it this way this time. There's 1 electron. This is a model of a hydrogen. Very unstable because it wants to achieve a noble gas arrangement. A hydrogen molecule, hear that molecule, the basic building block of molecular compounds, is H2. A single hydrogen atom, 1 hydrogen atom is what I have drawn. But let's hook it together and kind of show a covalent bond as 1 hydrogen hooks to another. So yet another hydrogen atom. It would have a nucleus of a single proton, no neutrons, 1 minus 1 is 0. And if I were to draw its outer energy level, I should have drew that closer. Its outer energy level and its outer electron. Now think about what I'm going to do in terms of dragging them closer together. If I were in Smart, I could click and drag these and overlap them, but I'm in a PowerPoint. So what I'm going to redraw, and literally I'm just going to bring these guys closer together, and maybe I'll just change color to help emphasize. Here is that first original hydrogen. Here's its electron. Here is that now second hydrogen. And what I'm going to do is literally overlap their orbitals. When I overlap their orbitals, and if I continue to just simply draw in, kind of finishing off that first solar system, think of this as the positive proton. Think of this as the electron cloud, and that electron is free to spin around either one of those nuclei. So when we think about overlapping orbitals, we form hydrogen bond, H, single bond, H. 1 hydrogen overlapping a second hydrogen, that overlapping of orbitals where electrons can share is the definition of a covalent bond. 1 shared pair of electrons is a single covalent bond. A shared pair. Overlapping orbitals, really creating in a dense electron area. That shared pair creates a hydrogen molecule. Let's just keep modeling a little bit. What about the oxygen? Going to my next slide, we have water, where oxygen ends up to be the central atom. Modeling what an oxygen, and if I just think about representing its valence electrons, I'm going to go back to a strategy that most middle school students have been through before. It's called the Lewis dot structure. And if I just kind of consider the last guy, hydrogen with its 1 valence electron represented by a dot, hydrogen with its 1 valence electron represented by a dot, and literally just bringing those 2 atoms close together, we form that single bond. Oxygen, that's going to be my symbol of oxygen, is going to attach to the 2 hydrogens, giving us a water molecule. And we actually end up with 2 sets of non-bonding pairs of electrons. Friends, all we're getting here is that the idea of covalent bonding, and actually much more complex than an ionic bond, So I'm just kind of seeding it a little bit. This is just a seed for a future lesson. Drawing Lewis dot structures for molecular compounds truly done to a master level would be an AP job. But we're just getting a flavor that these orbitals can overlap. When nonmetals hook together, we form what are called single covalent bonds. I can quickly model, and again, this is all I'm doing is just sharing some examples of covalent bonds when nonmetals group together. Sometimes we have to form multiple bonds. And again, the process is above our head right now, but that's okay. We can come back and shore it up at a later date. We're just practicing the nomenclature right now. I'm getting an idea just by seeing what are called the Lewis dot structures. You will not be asked to draw these, but I'm just asking at this point to consider what they represent if you see such a structure. A Lewis dot structure. Carbon covalently bonded to the oxygen. Carbon is a nonmetal. Oxygen is a nonmetal. When nonmetals bond together, we make a covalent bond. And that covalent bond is electron sharing between atoms. All I'm hoping is that from today's little video lesson, we see that a shared pair of electrons is a single line. So if I have a double bond, a sharing of two pairs, we call that a double bond in chemistry. I have a double bond heading in each direction to the oxygen, and a common molecule you've probably heard of called carbon dioxide, two shared pairs of electrons. When nonmetals come together to share electrons, the type of bond is known as covalent. Nonmetal plus nonmetal makes a molecular compound. We are not going to be asked to draw molecular structures in terms of Lewis dots, but if we see some of those, we can certainly consider those solid connecting lines represent covalent bonds. I think of covalent bonds as the exact opposite of ionic bonds. Therefore, ionic compounds have very, very different properties than molecular compounds. Our molecular compounds, those built of nonmetals sharing electrons, well, most are gases at room temperature, but I can find some examples of solids or liquids if I work hard. The most common molecular compound that happens to be a liquid at room temperature is water. H's and O's are all nonmetals, but most are gases. Some I can work hard to find solids. They have very low melting points. Ionic compounds had very high melting points. Ionic compounds, called salts, take a whole lot of heat to melt them. Molecular compounds, the opposite. Most often their gases have very low melting points. You've done it. You've finished the video notes on ionic and molecular compounds. By the end of this video, you have finished page 7 of your notes. Good work, team.